In Gen AI deployments, achieving the right performance with the right cost through Goodput or SLO-based inference is crucial. But finding the right configuration that balances the expected user experience with the ROI is extremely difficult. Parameters like throughput, context length, sequence length, time to first token, idle user time, TPOT, TBT, prefill throughput, decode throughput, and end-to-end latency all play a critical role. The key is to find the optimal balance between expected SLOs, the model and hardware used, and the inference runtime and its configurations. If these values are set incorrectly, the model may perform poorly, leading to a bad customer experience, wasted computing resources, and higher costs. For example, when it comes to human-facing applications like chatbots or virtual assistants, generating text faster than what a person can read doesn't actually improve the user experience. It takes approximately 200 milliseconds for a human to consciously perceive a stimulus and begin a voluntary response, marking the lower limit of conscious processing. And a Llama 8B model on Intel Xeon hardware delivers a TTFT of about 120 milliseconds with 30 concurrent requests. However, increasing the TTFT to around 220 milliseconds can more than double the number of concurrent requests. By strategically selecting a higher TTFT that still meets SLOs, the application can support twice as many concurrent users without impacting the user experience. In fact, aiming for minimal TTFT for such use cases results in compute wastage without offering any real benefit. For human-facing apps, it's much smarter to match the AI's output speed to how fast we read. In large-scale batch processing, like summarizing documents, there's no human in the loop, so faster generation means quicker results and better efficiency. In these cases, you have to optimize for the best possible concurrency and end-to-end latency. Now take a look at this graph. It shows the relationship between TTFT and throughput. Someone with little experience in model deployment might be tempted to aim for the best possible throughput for all deployments. But you'll also notice that the TTFT is much higher, which is not ideal. On the other hand, if you optimize purely for the best TTFT, you see a considerable drop in the throughput. So the ideal choice is to find a balance, a combination that gives you the best possible throughput at a reasonably low TTFT. That's what this green area represents. And this is just one example. There are hundreds of use cases out there, each with different optimal parameters. Trying to remember the ideal configuration for every single one just isn't practical. That's why we introduced deployment templates in Bud Runtime. Deployment templates are pre-tuned configurations designed for different Gen AI use cases. They help ensure that every deployment is optimized for its specific workload, whether it's a chatbot, summarizer, or code assistant. By using the right template, teams can drastically reduce the time and effort spent on tuning, and more importantly, they get the best possible performance right out of the box. Let me show you how it works. Say you're deploying a model. I'll pick Qwen 5B for this demo. Right here, you'll see a list of deployment templates tailored to different use cases. We've taken care of the heavy lifting. Over 150 deployment templates for various use cases are already researched, refined, and built into the Bud Runtime. If you're working on a RAG application, just select the RAG template. Bud Runtime automatically fills in all the recommended parameter values for that scenario. Or if you want to deploy for a different use case, say a chatbot, then you'll have a new set of SLO values tailored to that use case, ensuring the best performance from the model. You can tweak them if you want, but in most cases, the defaults are already optimized to give you the best results. Set the number of concurrent requests, and you're good to go. Bud Runtime handles the rest, making sure your model performs at its best for your chosen use case. For some of the frequently used use cases, such as chatbots, code completion, and text summarization, We have also tied these configurations to advanced inference optimization methods like speculative decoding, disaggregated prefill and decode, and others. So what is the real-world impact of using BUD templates versus custom ones you may provide? Just to give you an example, BUD templates for chatbots improve Goodput by 2 times to 3.14 times compared to a randomly selected custom SLO. For code completion, Goodput is 3.2 times higher with a 1.5 times tighter SLO, as BUD templates automatically activate disaggregated prefill and decode. For summarization, BUD templates deliver 4.48x higher Goodput and enforce a 10.2x more stringent SLO, thanks to automatic use of disaggregated prefill and decode, along with efficiency gains from balanced SLO configurations. So that's the deployment template in BUD runtime. It enables you to deploy GenAI the right way, even if you have no idea what you're doing. We are also introducing a new GenAI agent called Ask BUD to automate GenAI infrastructure deployment and management. One of the things you can do with Ask BUD is create ideal SLOs for optimal experience and ROI for your custom requirements, just through a chat. Stay tuned for more.